In this video, we'll talk about area and area of triangles and parallelograms. So let's talk first about area. So area is a two-dimensional measurement. And it's the idea of, say I have a square, and I want to say how much space does this square take up. And let's say, for the sake of the sake, that it's 1 unit by 1 unit. So it could be a foot, could be an inch, could be a mile, whatever it ends up being. It's a little bit difficult to describe it without talking about how the units matter. So in this case, we would say it is 1 square unit. Or, in other terms, sometimes it's written as 1 unit squared. And it's usually written with that little exponent of a 2. And both of these would mean the same thing. If I'm talking about 1 square unit, I'm talking about a two-dimensional space where you've got 1 unit by 1 unit. Now, area, at its core, let's say I have some kind of geometric figure, and the idea is how many of these are going to fit in here. Now, in this case, it might be a fractional amount, and that's okay. We're trying to measure how much space does something take up on a two-dimensional level. And that's the concept of area. So let's talk about parallelograms. So probably the most classic example of a parallelogram is a rectangle. Now, a rectangle has all right angles, 4 sides, and the defining trait of a parallelogram is that it has 2 pairs of parallel sides, meaning that they're in the same plane and they will never intersect. So if I was to extend these lines out, they would never cross. Or another way of thinking about it is that they're always the same distance from each other. If I was to consider the distance from here to here and here to here, it'd be the same distance. Okay? Now, if we think about what makes a parallelogram, it doesn't restrict us to just a rectangle. We could also have something more like this, a more classic example of a parallelogram, where it's a little bit on its side, but we still have the same kind of features going on as far as these sides are parallel to each other. So how we would find the area of a parallelogram. And if we think of it as a rectangle, which is the classic example, we try to think of how many little squares are going to fit in here. So let's say we had something that was 4 inches by 6 inches. Well, there would be 4 inches wide by 6 inches long. I would then say, okay, there's 24 little square inch blocks that I could fit in there. So the idea would be I'm going to take 4 times 6. Or, more classically, sometimes we call these, and I'm not a fan of these terms, but they are the terms that are used very commonly. You have your base and you have a height. Now, something that's worth noting here, bases and heights are always perpendicular, meaning there's always a right angle between them. This will come into play when we talk about this other blue example over here. But the area of a parallelogram is equal to the base times the height. Now, it's important to make this distinction because the typical thing when you're talking about a rectangle is to take the length times the width. However, if I was to do that with this parallelogram case, well, my length and my width aren't perpendicular to each other, so we have to have another measurement that will usually be given to us. We're looking at the height here. And in this case, we're looking at, okay, what is this height perpendicular to? It'd be this side, so then this side would be the base. And then we would use the formula area equals base times height. And this would be the main takeaway from this portion. Now let's talk about triangles and how to find their area. So triangles, very similar to parallelograms. If I think about a parallelogram, well, I could take it and I could cut it in half along the diagonal like this, and I've got triangles. And if I can imagine any parallelogram, I can always cut it into 2 triangles that are going to be equal in size. So the area of a triangle, and you may be familiar with the formula, is 1/2 times base times height. Or if you prefer, you could take base times height and divide it by 2. Both are the same thing. And again, we will need this height of the triangle. And then that would make this side the base. Now that's one derivation of where it comes from. Now triangles may also look a little different. Say a triangle looks something like this. Well then, we would have to extend the base to figure out what the height is. However, if we do that, we're still only going to use the actual side length that is perpendicular to. So your triangle may look a little different. You're basically trying to figure out, okay, how tall is my triangle? And we would measure that by going straight up from whatever the base is. And again, the important takeaway here is this formula. The idea is you take the base times the height, and you either multiply it by a half or divide it by 2. Both are mathematically equivalent. So let's do a couple of examples. Let's say we want to find the area of this figure. First question is, okay, what kind of figure is it? I would think it's a parallelogram. So let's figure out what our base and our height are. So the height is usually where you want to start. And I'm thinking it's this 5 number. Because we're looking at this height, we're measuring how tall is this parallelogram. We wouldn't measure along the slant here, because you don't measure height that way. So we know that our area is going to equal 5 times something. And then I have to think about, okay, what is this perpendicular to? Well, it'd be this side or this side. Since we know the measurement for this side, we could say it's 10. So the area, and let's say it's in inches, the area would be 50 square inches, or you can write it as inches squared. Both of them would mean the same thing, so you could write this out as 50 square inches if you prefer. Both mean the same thing, and that'd be how we'd find the area. Let's talk about a triangle now. So hypothetically, let's say we're looking at an equilateral triangle. Again, we need to find the height first, which I'm thinking is this 4. That's how tall the triangle would be at its peak. And then it looks like it's perpendicular to this side, this 6. And then I can say the area is equal to 1/2 times 4 times 6, which means that the area is going to equal 1/2 times 24, which means that the area is equal to 12. Since they gave no units here, we would definitely want to write units squared, whatever we're given. Let's call it units squared. And it's very important when you're talking about area to always include square units. There's a huge difference between inches and square inches, as we kind of talked about in the beginning of the video, so just be very, very cautious of that.